Here the condition has been given that there is a function and there can be infinite rectangles that can be formed within like this, um, using the symmetry of the function. Now what we have to do is we have to find out the coordinate of C such that the area of the given rectangle is maximum. Now, since we are talking about area, it is as important as finding a single function in one variable for the area. Now let's find out. Okay, if I take this as x, this length as x, the corresponding length is y. This length is y because this is the coordinate of the C. Now, also we know that y is nothing but e to the power negative x squared. So when we find out the area of entire rectangle, it's going to be 2x, that's the length of the triangle, a rectangle, times the width, which is y. Now, since y is given by this function, this is the output, which is e to the power negative x, the area is 2x times e to the power negative x squared. So that's my function to be optimized. Now, here, what we'll do is we'll do derivative with respect to x. So dA by dx will be product rule and chain rule both. So derivative, so this is u and take this as v. So derivative of 2x is 2 e to the power negative x squared plus 2x as it is into derivative of e to the power negative x squared times negative 2x. This is the chain rule. I expect you to know the chain rule carefully. Now, e to the power negative x squared, you take it common and become 2 minus 4x squared equals to 0. Since we know that e to the power negative x squared function can't ever be 0, you can see that this is horizontal asymptote and it's going to be always positive. So this can't be 0, so this must be 0. So that gives you x squared equals to 2 by 4, gives us x is 1 by 2, x squared is 1 by 2 and gives us x is plus or minus 1 by root 2. So one of the coordinate, that x coordinate we got is 1 over root 2, another possibly, possibly becomes is this one, which is negative 1 over root 2. So now we got the x coordinate. To get the y coordinate, you plug in the function. So you'll get y equals to e to the power of, let's say, negative 1 by root 2 squared, which is y equals to e to the power negative half, which is 1 over root 2. So this coordinate, which is 1 by root 2 comma 1 by root e of C, gives the stationary area. Now, to check whether it's a maxima or minima, it is interesting to draw the sign diagram of derivative. Like sometimes I would not recommend to find out the double derivative every time, and we make use of the sign diagram of single derivative, dy by dx. This is like 1 over root 2. If I take x coordinate here, if I take a value here, like for example 0, and plug in the derivative. So if I take 0 here, it's coming as positive. If I take 0 in this part, because this will be 2 times a positive number, that's positive. Now if I go other side, like for example, if I take 1, it'll be negative because 2 minus 4 will be negative times the positive, so it'll be negative. So as the slope is changing from positive to negative, the expression will have a maximum area at this x coordinate.